Hello and welcome to our first enzymes video. So for enzymes, we are moving on to more specifics of how they help our body. Now, remember, we mentioned a little bit of enzymes during the protein section of our biomolecules because enzymes are a protein. So let's get into more detail about enzymes today. We have chemical reactions constantly occurring in our body. If you remember this from 7th grade, you'll remember that you have things like digestion, for example, is a chemical reaction in which your body breaks down the food it's eating, right? And we talked about the different biomolecules in your food. So of course, you're going to need to know how your body processes them and how we're able to get the nutrients that our body needs from those foods. So with chemical reactions, we have these formulas here called chemical equations, okay? So the formulas are each individual part of the equation, and then when you add them and get a result, that is the actual equation. We covered this slightly in the summer bridge when we went over that chemistry unit. So just remember the formulas are the individual pieces, the equation is the whole thing, okay? And it's divided up into two parts, the reactants, the before the arrow, and the products after the arrow. So just like in a formula for math, for algebra, for any class that you've seen, you have your operation, an equal sign, and the answer, right? This is similar. You have your operation, a yield sign is what we call this arrow, and your product. So the operation, the reactants, are what you're putting in. Think of it like a recipe. These are your ingredients. This is what you're putting into your reaction, right? Then the reaction happens when you join these chemicals together and you get a product, a result. Just like when you're making a cake, right? You add the ingredients, you bake them, and then you get a cake. So this is a chemical reaction. You add your ingredients, the reaction happens, you get a product. These are just vocabulary words you're going to need to remember. They are getting added to your Quizlet, don't worry. Now, chemical reactions are going to need some energy as well, okay? So for example, when you light a match to get a fire started, right? That's some energy that you're adding in so that the fire can happen. Not all chemical reactions require energy, but a large amount of them do. Now, the energy required to get a chemical reaction started is what we call an activation energy. Okay, so you'll see these curves. You'll start with the reactants. So think of the baking a cake part, right? So you're adding all the ingredients in, you're mixing them up, but the cake isn't going to bake itself, right? You have to put it in the oven. You're adding energy from the oven. So it's a similar idea. Here you've got your reactants. You get to the activation energy, so the amount of energy needed for the reaction to happen, and then it's able to create that product. Okay, so that activation energy is the distance from the reactants to the top of the curve for this reaction to happen. So if you see these graphs, that activation energy is that distance from the reactants to the top of the curve. Okay. Now, we have certain enzymes called catalysts that are able to help us do this activity faster. So they decrease the amount of energy you need in a chemical reaction. So for example, this curve here, the first one, the light colored one, is just like the one you saw before here. You have your curve of how much activation energy you need. Now, if you add a catalyst to this reaction, this catalyst is going to lower that activation energy. So you see how this curve is much less steep than this other one. So it requires less energy to get this done. That is how a catalyst works. It decreases the energy that you need in order to speed up a reaction. So you're able to get to the products a little bit faster. So if you have a rock that you're pushing up, right, it's going to take you a lot of energy to push that boulder all the way up. But once it's all the way up, gravity is going to have a very easy time pulling it back down. So that's what you're doing with a catalyst. Instead of you pushing that huge boulder by yourself, what if you use a crane, right? You're able to put it where you need it, and then it can roll back down really simply, a lot faster than if you wait until you're able to push it all the way up. So the crane here would be our catalyst. You're adding something extra that helps ease up your work. Okay, in living things, we have a lot of these catalysts, which are, like I mentioned earlier, proteins. The name of these catalysts for living systems is enzymes, okay? So enzymes are just proteins that help us speed up chemical reactions in our body, okay? They are catalysts that decrease that activation energy in order for us to get a chemical reaction done faster. An enzyme has several parts, okay? The enzyme is going to have something called an active site. So enzymes look kind of like this in usual drawings that you get. These sometimes are called lock and key models, where pieces fit like a lock and a key. So these enzymes have this area where a perfect piece of information is going to be able to fit in there. And they're able to speed up the reaction for that information. So that area where the other piece is going to fit is called the active site, okay? The piece that fits that area is called the substrate. And then once they are combined, this is called an enzyme substrate complex. When they are bound together, that's a complex. Think of an apartment complex. There's a bunch of apartments put together. So the enzyme and the substrate together, enzyme substrate complex. And once they are together, this is going to help accelerate that chemical reaction, right? Turning this substrate into these products. So now they're going to leave the enzyme as two different things from the one that they started off as. This is one example of an enzyme process, right? So you have a piece that fits into the enzyme, the reaction happens, and you get your products out of that, okay? And then you continue using these enzymes. So these words that I need you to remember: active site, the place where they fit; enzyme substrate complex, when they're bound together; and the products are the pieces that you get at the end from the beginning substrate. Now, once this reaction has happened and the products have been changed, the enzyme is still looking the same. So if you look at this drawing, the enzyme looks the same as it did in the beginning, and we are able to reuse it several times, okay? Now there's another thing called coenzymes. Sometimes you'll see these where it's like the enzyme is not a perfect match for the substrate you need. So you get a little coenzyme, a little piece to add in between so that the substrate fits better, okay? You might just see this once or twice. Don't worry about it too much. Coenzyme is just a helper for that activation site to fit better that substrate. Now, like I said, there's two types of enzyme models: the lock and key model and something called the induced fit model. So the lock and key, really just like a lock and a key, you have the perfect shape, one thing fits and it'll react. And if it does not fit, there won't be a reaction. So like when you're trying to put in the wrong key onto your door, you're not able to open it because it does not actually fit that keyhole, right? So same idea here. If the substrate that you're putting into the enzyme does not fit perfectly, there is not going to be a reaction. It's not going to do anything. It's not going to help you accelerate anything. There's just not going to happen. There's nothing that's going to happen, right? So the function of the enzyme is useless if the substrate does not fit. And the induced model is where you have pieces that adjust a little bit in order to fit, okay? So usually they come in close to, but not perfect, and it just kind of wiggles its room into fitting into that area, okay? So the lock and key, it's a perfect match. The induced model, it adjusts a little bit, but it's able to fit. Okay. And that is it for part 1 of enzymes. I know this was probably a lot, and today's video is over the weekend, so you have plenty of times to rewatch it and get this information through. Make sure you watch it again before the beginning of class on Monday so that it's fresh in your mind. And that is it for me today. Make sure you are aware of all the information here. There's a lot of vocabulary. If you need to rewatch this and slow my speech down, feel free to do so. And that is it. I'll see you on Monday. Take care. Have a good weekend. Bye.